Welcome, everyone. Thank you so much for joining us today. I am Jessica Rodriguez, and I am the Industry Engagement Officer for the Data Science Institute here at Columbia University. Today's seminar is an iCubed, which stands for Institute, Industry, and Innovation. These seminars connect our industry affiliates to our students and the larger Columbia community to explore topics at the forefront of industry. We invite data scientists, engineers, or researchers from our affiliates to give a talk about a recent project or case study. During these educational events, we encourage attendees to ask questions via the chat feature. Today, we will have a data scientist from IBM speaking. Today's talk will be Key Tenets of Data Governance with Enterprise Data Lake, as you can see the title on the screen already. And it will be presented by Roochir Purani, who is a Chief Executive Data, I see a different title on the thing, Chief Data Executive, Enterprise Information Management at IBM. Thank you and welcome, Roochir. Thank you for joining us today. Handing it over to you.
Thank you, Jessica. Thank you, team, for organizing this session. I think it's an excellent initiative to drive awareness around data and its need across the enterprises. And with that, I'd like to open the session up with a key understanding and a background around this topic is that the key tenets around data governance and delivering that data governance approach with enterprise-wide data in a fashion that is usable by business, in a fashion that's usable and consumable by users who really care about data. And we often refer to that terminology as the availability of the data and the repository of data as a data lake, but it could be just referred to as any repository that allows us to start tapping into the business value of the data. And with that, as Jessica introduced myself, I have a number of years of experience in managing the data across different enterprises, different industries, and supporting the initiatives around data transformation, data governance, and data integration with data quality. So it's my privilege to be here, and I'd love to talk about a few key areas. So the agenda for the discussion is going to be around understanding really why we need to have some repository, some data lake that allows us to get into the value of that. So there's the business aspect to that. There's a need. In order to drive some activities around data, we absolutely have to have an understanding what is the rationale to achieve the outcomes for the business. So that's the first part. The next, we'll talk about some of the principles around a data architecture and governance principles that go into creating a foundational layer. Key principles around the designing of a solution that provides the value to the business. And then subsequently, we'll look at what are those key tenets that drive the value on a sustained basis. I'd also like to introduce some of the topics which are new topics, the data lakes leading into data fabric. So there's emergence of data fabric. I'd like to introduce that topic and I'll drive the analogies between the two areas. And then subsequently, we'll go into some of the key components of data fabric, which also align very well with the enterprise data governed data lakes as well. Finally, I'd like to wrap it up with key skills as we prepare to deliver solutions for the business using the data, enterprise-wide data, and the data lake concepts and data fabric concepts. So with that, I'd like to talk about the key benefits of the data lake, especially in the cases of the enterprise where the industries and the companies have wide variety of data. And not only that, data continues to grow at multiple places in different fashion, at different rate. Some of the data is sitting on-premise on their large enterprise resource planning systems, ERP systems, or data warehouses, and they continue to be utilized for various needs. Other data sets continue to get created, consumed, utilized on cloud, because as we know, a lot of applications are sitting on cloud and they're only available on a cloud as a service. So you have a cloud set of applications that enterprises have to deal with, and you have on-premise applications that they have to work with, which both consume, work together with data going back and forth between on-prem and cloud. And what's important there is when business looks at tapping into the value of the data repositories working in different siloed applications, whether it's on-prem or cloud, it's hard to get the value out of it. What they end up doing is create additional layers of activities and then create cost overhead. They spend numerous hours of just looking at data from one place to another place, bringing it into Excel, and then work with that. And that is the true cost benefit that they are after, the business is after, to simplify their lives on tapping the value of the data, no matter where it is. So that's the first aspect. The second aspect is leveraging the data as a business asset. Once it's in a way so that they can start understanding what are the competitive advantage of having the data, whether it's on-prem or cloud, and how do we utilize that to drive the engagement with the customer, to provide more services, a more approach in creating innovative ways to engage with the client and tap into their preferences that align with the products and services that the enterprises are offering. And that generates the revenue. And that's what the business is all about. They're generating the revenue by enhancing and increasing the customer engagement. And then lastly is creating the awareness around the enterprise to ensure that the data that they are going to be using and providing and driving in it and making decisions upon is highly trusted, high quality, so that there's less ambiguity and there's high amount of trust at every point in time throughout the data life cycles. So these are the key benefits thereafter, is to have trusted data where they can make informed decisions without having to spend numerous hours in understanding where the data is coming from and how am I going to utilize it to drive the business engagement with the clients, to offer the products and services. This results in something that the businesses can tap into to create a specific approach that allows them to say, I'd like to tap into the value of the data. I understand the business cost benefit and the business benefit of this. Let's start on implementing something to deliver the value of the business, value of the data. The first step is to understand the planning and acquisition of the data. And as we know, it could be spread across different areas, on-prem cloud or geographies and different systems altogether. We must understand how best to acquire that, ingest that, and start creating a repository. That repository has to be established in a governed manner so that it starts introducing the amount of trust, compliance, and any risk associated with the data privacy. And then finally, driving that outcome, which is around providing the services to the business, either in a self-service mode or an assisted mode, which allows them to engage with the customer with the value of the data. And we're going to look at that in the next few components that we're going to talk about, is how does that come alive, is driving the business engagement. The first part of the data acquisition and creating the data foundation is having a robust architecture. And that architecture is sustainable, should be sustainable, and should be able to handle the volume of data. And not only that, but ability to tap into the value of data at any point in time in its entire life cycle. So that architecture has to support various needs at various points in time for this enterprise data. The second tenet is around reduced time to insight, which means going back to the point of time that is spent to analyze and time that is spent to drive the outcome with the analyzed data is extremely important. That insight based on the analysis that drives the value for the business to enable the customer engagement, offer new services or products, is all about making the insight work for the business. And that has to happen a lot quickly. If it takes to understand whether a customer is even relevant for us to do the business with more than 3 months, by the time the opportunity is even lost. So it's very critical and important that we deliver the value of the data a lot faster. The next one is about high degree of data quality. This is about ensuring the trust is sustained and is well understood. The data quality has to be consistent across the enterprise, across the items and the products and services and the customers that they're looking at, but also has to be reliable and accurate, conforming to the standards, conforming to the business needs, so that there's less manipulation or transformation being done ad hoc at some point in time in a spreadsheet. And then a lack of governance creates that problem challenge, and that's the problem we need to avoid, having the right factor right from the baked into the principle of data lakes. Enabling the data so that the right people have access to it with high trust and amount of security and privacy. We all know that there are so many compliance and laws and regulations around data and sensitivity of data. Every enterprise goes through understanding criteria to whether to put the data on the cloud or whether to generate data on the cloud, who has access at one point in time, and how will they have access to it, that their data. And this is tying into the client or customer specific data that has implications in number of regulated compliance laws. GDPR for Europe, HIPAA compliance for some of the pharmaceutical companies and medical companies. And there's need to protect the data and ensure that it doesn't get in the hands of incorrect people or the people who are not supposed to see the data. And therefore, it's extremely important that the architecture and the success factor of the data lake supports that initiative. And next is driving the self-service awareness of the data by utilizing data catalog and ability to utilize the data in a way that requires less involvement from the IT team members, so that the business users do not have to continue to ask, well, how do I handle this data? How do I bring this data to so that I can make decisions on that? Should be a lot more self-sufficient and driven through the approach of self-service. And the last one is data monetization, which is where once the value is created, you may start leveraging that new set of information or insight to drive additional business growth and create ways to engage with the client and monetize the data, potentially offer the data itself as part of the service. And a lot of enterprises often curate the data, prepare the data, and carve out a set of data from their enterprise data so that they can sell that off potentially on the market. And that becomes data provisioning for external consumption. And that's really powerful as well, so that your data starts to turn into the value and generates the revenue itself. With that in mind, I wanted to bring this concept of data fabric. Data lakes have been around since last decade or so, and they've been maturing over a period of time. There have been cases of failed data lakes where if the data lake is not governed and has not been well thought through the principles and the tenets that we just looked at, of course, there's going to be a failure and it will fail to deliver the value to the business. However, the next step in the evolution of data repositories, coming from data warehouse to data lakes to data fabric, is an approach where you now have multiple data lakes or federated data lakes across the enterprise, where the repositories are built for purpose and they stay as governed in that local repositories or regional repositories. However, a mechanism is laid on top of it, a mechanism to virtualize that data so that a virtual fabric is created between the sources of truth or trusted data sets and data repositories across the enterprise. That creates a layer on top of all of the repositories, whether it's on-prem cloud or geographies, and creating a virtual layer of fabric. This delivers the data through the self-service catalogs or providing the data to the right consumers at the right point in time. And then the most important aspect of this data fabric concept is that it is agnostic to no matter where it's sitting, what system it is sitting in, what is the underlying platform or data repository it's sitting on. However, it has the ability to connect to them in a virtual manner so that it can start exposing the relevant data to that service-based catalog. In addition to that, the data fabric starts to tap into advanced analytics, AI-based, machine learning-based components that enables value generation a lot rapidly. As the data continues to grow, the techniques of analyzing the data has to improve on, and machine learning-based algorithms help identify true insights a lot faster. These machine learning based or AI based algorithms applied on the data sets at a variety of places can generate the value for the business a lot faster without them having to apply complicated algorithms. And that's where the data scientists, team of data scientists come into picture to create that value very rapidly from multiple repositories. We're going to look at what that data scientist skill sets are needed to enable the business to create the self-service in the next few slides. But before that, the whole premise of the data fabric is to drive simplification from ability to acquire and ingest the data, ability to access the data, and ability to provide the value to the business. All of them has to have simplified layer and simplified component to that, so that it doesn't become a complicated, hard to maintain, very expensive architecture to support the future needs. So that is the key aspect of this data fabric that I'd like to talk about. Some of the components within the data fabric that are essential to create that solid fabric and robust fabric is ability to quickly discover the data and ability to enrich and improve the data quality on the fly with semantic discovery, so that there's less human intervention and you are applying and advanced algorithms to understand the content, understand the semantics from the business perspective. And that is an extremely important aspect that becomes an automated approach in a data fabric. So it's no longer having to write series of code or a heavy amount of code just to enable understanding about what's really happening to the insights. So it's a lot more automated because it's machine learning based or advanced enrichment algorithm based to approaches to drive the value. The next one is the unified governance and compliance. We've seen that industries struggle to bring data together at all points in time because they're constantly in tremendous amount of growth. The unified governance of metadata, to be able to identify the metadata and create a canonical structure that enables the semantic layer at a consistent layer throughout the enterprise, is important. You don't have to bring the data together, but you must understand the semantics of the data so that it becomes governed and well understood throughout the enterprise. For example, a product being referred to as a material on another side of the business and organization within the same organization could be completely different, because a raw material may be a product from a supplier standpoint, but it is a product from the consumer standpoint when they're about to sell, when it's a finished product. So this type of semantic is extremely important, especially at the time of driving the insight and engaging with the customers. Business partners, additional terminology such as legal entities, and engaging with the clients or calling them as clients or customers or prospects or accounts. These are just different terminologies, and unifying these in a governed manner is extremely important. That comes with standards and policies, and according to the local and regional, that could be based on geography, based on the organization, business unit, and they may all have their different rules on how they identify or align themselves to certain terminology. And that's important understanding and discovery around the data governance and compliance. Then the next step is around applying the components that help us drive the integration, which we talked about. Having multiple repositories spread across different geographies or different platforms need to have intelligent way to bring the data together. And it's no longer the time where a long process of creating connections between one system to another system, but is a lot more automated, streamlined, so that the data acquisition, data virtualization becomes streamlined and can sustain the volume of data and the types of data that will flow through the pipelines. And that integration supports the inherent changes that might be happening in each of the siloed repositories at a virtual level a lot rapidly. So it has to be really smart and intelligent to drive those integration points in a well manner. Otherwise, you would have a mid failure in the middle of the analysis, and that could be detrimental to driving the value of the business, or value for the business. And then lastly is the orchestration and the overall data lifecycle, visibility is important, because in order to deliver the data end to end from the data conception or data inception perspective all the way to data destruction, having that orchestrated life cycle and visibility of all the points in data is extremely important to apply the value of advanced analytics at every point in time. So you would create a repository that would be a raw view of the enterprise data, and you would have more virtualized, aligned view of the data set that brings the value to the business. And at that time, it improves the visibility and the orchestration across these different disparate systems in a virtual manner. And so these key components are extremely important to drive the concepts of data fabric coming in from the data lake perspective. Some of the key capabilities based on those components are laid out here, and I wanted to share them with you, that they could sit on any type of cloud platform out there. What you're seeing here is several different cloud platform in the bottom section. However, at the top, you have needs of data from the business users or data users perspective throughout its life cycle. During the time of creation of data, build and test and orchestrate and deploy. These are some of the functions and the capabilities that are needed to deliver the value. They could be predefined, self-service enabled, or driven through the catalog, or driven through the business need based on the requirement and the need of the business. They all bring together that self-service and smart integration component or intelligent integration component that we talked about. And these are the capabilities that allow us to bring the ingestion of data, transformation, the preparation, and virtualization, along with bringing the data in near real time or real time from different sources. That creates the visualization for the business to drive the value, and supported by the governance and the compliance to ensure the consistency and the high amount of trust. The data governance components of and the compliance is extremely important, along with the data quality. So as you can see, these are the key capabilities that must exist in a governed enterprise data lake leading into the data fabric. Whether the data comes from any of the cloud, which is cloud or on-prem systems, they must have a way to discover the metadata, the way to automatically discover semantics, and a way to drive all the changes and updates in a seamless manner, to deliver the self-service in a seamless manner. And that is the true nature of the data fabric driven approach. I have provided here for the reference a data governance, a governed data reference architecture for data fabric. You can utilize it, and what it shows you at the bottom layer, it utilizes the structured and unstructured data repositories. I'll give you some examples in the next slide. Is the types of data that can be utilized on a structured unstructured basis. But that set of data set, structured unstructured data sets, whether they're coming from one enterprise or multiple enterprises, they're all being consumed and virtualized at the next layer to create advanced analytics through the query engine. There are some technology names that are written here. Some of you may be familiar with them very well. However, they vary based on where the data fabric is being established, created by the cloud provider or by the certain technology, open source technology, or some of the vendor specific technologies. But these self-service query engine or self-service catalogs are tied to a key capability that we just looked at. Of course, supported by the operational excellence to ensure that it continues to function and deliver the value, and has tight governance and controls and security and compliance at all points in time throughout the life cycle. This creates the value chain for data, supporting the data science, the business intelligence, and advanced analytics with AI applications. They can be consumed on mobile devices, could be consumed on any advanced reporting layers or visualization layers, but it all drives that value that we are all after. Here is an example of a structured data or unstructured data coming in in two different patterns. And this is an example of game company that publishes games on the internet, driving through Amazon-based cloud infrastructure. What you see in the bottom layer is a batch-oriented because of the volume of data, because of this, the systems that it's providing the data from and to, does not need to have near real-time capabilities. So therefore, it runs with a batch-oriented, traditional, periodic, frequently updated data set. And it uses Hadoop, which is a big data platform to support unstructured and structured data at a large variety and large volume. Top layer is near real-time pipeline, which uses a lot more streaming approach of data sets. As the users start engaging into the game and start creating the data as the game goes on, the streaming data sets are streamed through that, and you have the top layer coming into picture, and that enables data acquisition in near real time and supports the value to the business on how many users are using it, what kind of activities is happening in the game, and so on. So all of these are captured in a way that continues to deliver value as the usage happens, the data gets created, the data gets applied, stored, curated, and delivers value all the points in time. And that's a view, a horizontal view of that data lake described here. As I mentioned, there are different types of data. So you have structured data and unstructured data. They all come together in a data lake in a one repository or virtualized. However, it's essential to understand whether the data has to be prepared and aligned together, whether it's a structured or unstructured. But in order to drive the value of the data, it has to match to the business need. As you can see on this chart, the top two layers, which is flat file sources or databases on premise or on cloud, they are a lot more aligned towards being structured data sets. The rows and columns and traditional databases are part of the very nature of those structures. Cloud applications are becoming structured and unstructured. So therefore, they contain hybrid data sets. On the right-hand side, the audio, video, file documents, PDF documents, these are the types of unstructured documents, contain some structured information, but they are highly unstructured. They may contain values in different places. So you need to ensure that you have created a catalog of these unstructured data and tie them with the curated structured data sets to enable the linkages between structured and unstructured data. Additionally, the lower sections on the right and the left, which is sensors, plant, manufacturing, and IoT, these are the types of data coming in from high amount of data volume being generated on those endpoints, bringing the data into data lake, enabling the connection between the structured data set that's coming from the cloud databases or on-prem systems, and driving the value for business. In addition to that, additional unstructured data sources could be from social media feeds, such as Facebook, Twitter, Instagram, and so on. These unstructured data sets continue to provide value to the business as well. And when they are streamed into a data lake, a repository, a catalog of service or a self-service can enable the value for the business very rapidly. With that comes the key benefit. We understand that there's data fabric aspects and enterprise data lake, and a governed data lake has to deliver a key value and a key business benefits. So the self-service is important. I'd like to iterate that it has to be based on the purpose and the need, the fit for purpose, and also has to deliver the insights across the company. Otherwise, it would be just a siloed activity, and that's also okay. And I'll talk about one additional concept that is emerging beyond the data data lakes or the data fabric, which is the data mesh, where you could have the siloed repositories. However, they are highly governed repositories, continue to deliver value, but with high amount of governance across the enterprise. So there is still a semantic layer that is consistently used across the enterprise, enabling the insights to be in the right manner. The additional benefits are on the governance, because these lakes in the data fabric, architecture has to be embedded with governance. There's no time to go back and fix the governance problem if it is not well thought or forethought ahead of time. The amount of trusted data that will continue to be generated, continue to be analyzed and curated and prepared and delivered for the business purpose is going to be a lot more faster. And therefore, automated trust and automated compliance is extremely important at all points in time. And then finally, compliance for the privacy and regulatory compliance for a lot of enterprises and industries is extremely essential. And it has to be part of the second nature in terms of building the self-governed or governed data lakes. As I mentioned previously to you, that there are a few technologies I showed it to you. There's so many different variety of technologies that can be applied to be utilized in driving the value for the business from a data lake or data fabric. The key skills are listed here, and they're broken down into 4 major areas. One is driving the insights, which is applying the analytics on it, advanced analytics components that uses the discipline of data science, the group of data scientists with a background of statistics, mathematical understanding of how to rationalize the data, how to look at the data in a way that is giving them the highest, most effective time-driven approach, and analyzing large sets of data very rapidly, applying innovative AI-based algorithms and applying machine learning components, and then delivering that data to data visualization layers so that they can visualize the patterns, visualize the relationship between structured and unstructured data sets. And that requires creativity, ingenuity, innovative thinking, outside the box thinking to deliver highly effective analytics across the enterprise. The second skill that's needed is data quality, understanding the data quality inside out. Data quality begins with applying the business rules and the standards that are defined by the business. These rules help identify whether the data conforms to certain standards or the business rules or not. That activity is understood as data profiling, to understand whether I have identified data sets that conform to a certain rule or not is done through data profiling. Whether I have a complete record set in the data that I expect to have the data is part of the data profiling activity. Whether it's complete record for the business purpose, whether it's accurate, whether it's relevant, or whether it has the right value, the valid values for the business to take the decisions on is important. And those are part of the profiling activities. The semantic layer on the metadata and semantic layers on structured and unstructured data layers help drive the data quality rules in a consistent manner, whether it's a structured data or unstructured data. The next skill that we need to deliver the value on data lakes is data governance. We talked about having understanding around privacy and compliance, but those are not it. These are additional ones, which is data standards, ability to understand the standards that may be industry specific standards, that may be standards that are tied to the regional or the business unit themselves to support a common vocabulary across the business. That enables tighter, clear, concise communication about business operations and the data needs without any ambiguity. And that drives the data governance component. So to be able to enable a data fabric or a data lake on a fabric allows us to ensure that data governance is embedded right from the beginning and with these key skills as identified here. And then lastly is data integration skills, ability to understand the whole concepts of cloud versus on-prem, ability to understand the underlying ways of securing the data, providing the data, APIs, to be able to call the APIs from one system to another system, and various ways of consuming patterns or delivery patterns, near real-time versus batch integration patterns. These are some of the ways of handling the data movements across the data lake or data lakes or the data fabric itself. It could be horizontal data integration. It could be vertical data integration. At all points in time, these pipelines, which are pipelines building data movements between one repository and another repository in a virtual manner or a persistent manner, has to be looked at very carefully, because the data governance and the privacy continues to apply even at the data integration layer. A lot of enterprises do not want their data to be transferred out of certain regions, certain locality, or certain business unit. Whether it goes on a cloud is a completely different matter. But even on the cloud, it cannot cross the boundaries of certain countries and geographies. And these are some of the compliance that are part of the integration, very integration needed. So there is a little bit of tie of that, but having that strong understanding of different technologies and how cloud to cloud connection work, how cloud to on-prem connection work, and how the data can exchange between them without having manual intervention periodically is extremely important. And bringing the automation aspect during integration is extremely important for delivering the value. So these key skills, as highlighted here, are the next generation skills that help you build solid, robust architectures that we talked about in the key tenets previously, but also continue to deliver business values over a long period of time and make the data lakes and data fabric very foundation of the enterprise data platforms and data architectures. With that, I want to also talk about key points on kinds of skills that you may have come across. There are some useful skills and there are not useful skills. So a lot of enterprises, when they're planning to support these business needs to create and establish data platforms or data lakes, there are certain key skills extremely important. AI, machine learning, security, statistics, and understanding in data science, data visualization, and business intelligence are extremely important. Everyone must plan and learn and acquire those skills very rapidly. And they're very useful because that's where the most of the work is being happening. There are not so useful skills, traditionally very important, but not so useful anymore because we have created an automated approach to drive the activities. For example, mathematics or statistics or data warehousing. These are traditional skills, still relevant and important because they build the foundation for those advanced skills, but they're not so much useful right away. So if you plan to acquire them, acquire the top layer first and practice them, learn them. However, the other ones, you may choose to plan to support your learning activity much later on. You may even ignore them because they are time consuming. They could require a lot of effort needed to understand what's really happening. So deep understanding of statistics is really not needed, but a statistical model understanding to apply the right heuristics on the data sets is extremely important. So that is that subtle difference between statistical programming versus statistics itself. Another example is about spreadsheets and data cleaning and financial analysis. All of those, these are not so time consuming. Anybody can do them very easily, but are they truly useful in these governed lakes? No, because they naturally converge human psychology to continue to work in the siloed views or continue to work in spreadsheets because that's what they feel comfortable with. They will end up doing exactly that. So it's really not useful in the cases where we are aiming for creating a robust data fabric and a foundation for strong data lakes, but it can create a problem and challenge. However, the concepts of managing data in spreadsheets with the rows and columns, the concepts, data cleaning and data profiling approaches, and understanding the analysis and impact, the financial impact on the data is extremely important because that allows us to drive the value and the insights and the use cases a lot faster. Those were the key skills. With that, I want to open it up for any questions from any participants, and happy to answer any questions and provide any insight as needed.
Thank you so much. If anybody has questions, please feel free to drop them into the chat. Well, we wait to see if any questions come in. There are some questions that we like to ask our iCubed speakers. about life as a data scientist. And I'm hoping I can poke your brain a little bit about this while we wait for some questions to come in. As a data scientist, I'm working with this. What does a typical day look like in your office or for you as a in this role?
Excellent question. Typical day in the life of a data scientist is to understand the principles of the guiding principles of the environment, the data platform that they are working with. The business outcome and the ability to really rationalize the outcome and the value of the data is important for a data scientist. If they're not clear, they would really be spending numerous hours in time-consuming ways of figuring it out, how to apply a machine learning component or an AI-based component. So first, look at the output that's really needed. What is the value that we're going to be delivering it? And then do that creatively with high amount of creativity. So a data scientist would apply one or more ways of delivering that value. They would take into account predefined AI-based models that are already available, trained, highly trusted data models, and then start leveraging them to deliver the business outcome. So for example, if the business comes to the data scientist, the team of data scientists and says, I'd like to understand how are we doing in terms of Asia Pacific market for certain products that we have recently launched, and we want to now introduce those products into European market. With this kind of a long question, they are after business growth and expansion. A data scientist would take this and apply in two manners. One is, do I have all the data to prepare the outcome that is needed? That's number one. And number two, do I have predefined models that have been previously trained and trusted, which has already been applied on acquired data sets, whether it's the data coming from structured sources of Asia Pacific region or unstructured sources of Asia Pacific region, doesn't matter. And then combine that with additional data sources from European region to create what-if scenarios. These what-if scenarios, coupled with AI advanced machine learning algorithms applied on the data sets, will create a visibility for a data scientist to first prepare an output that says, it seems that a product launched 3 months ago in Asia Pacific had sentiment of highly welcomed product, but it lacked certain features and functions. In order to introduce anywhere else, especially in Europe, we know that the trends of the consumers is highly adaptive to certain new products. We must introduce that new feature before we go to market in Europe. That decision would need to be coming out of the data analysis work that is being done out of Asia Pacific, key gaps in Europe, so that business can make the right decision and take the appropriate actions and steps needed to prepare to go to market for Europe. So a data life of a data scientist requires to think through that creatively, that business outcome, and then apply the appropriate functions that we just talked about. Hopefully that answers your question.
Yes, absolutely. Thank you so much. We have some questions that have come in, so I would like to ask the first one. Are there emerging database structures and stacks that look most promising for heterogeneous data that includes larger files, e.g. high-resolution images, with associated metadata that is stored in structured, e.g. documents?
Yeah. Yes, excellent question. Number of cloud providers have created databases which require acquisition of unstructured data sources and bring data into a repository, such as images, PDF documents, videos, audio files, and so on. These are based on loosely defined structures. So they are not based on tightly defined rows and column structures, but they're loosely defined structures. So therefore, every record set has its own conformity, allowing you to store and retrieve highly unstructured data within milliseconds. If you think about the searches that are happening on Google on a daily basis, highly unstructured searches, the results that are coming back to us are in milliseconds. In the same way, these repositories on AWS, there are NoSQL-based repositories. These databases are extremely powerful. They can store millions and billions of records and can retrieve the records with a rapid rate. And that creates value for retrieving the data, analyzing the data, which is tied to this heterogeneous data set with structured and unstructured data. Hopefully that answers your questions.
Thank you so much for that response. And our next question is, what is the tool to create and maintain such a data fabric? Is this a service provided that a company will simply plug and play?
Excellent question. Data fabric is not just one tool. It's a collection of tools that deliver different capabilities and functions that we looked at. These functions and capabilities comprises of multiple tools, creating layers, a virtual layer of data sets. So it's not one tool. However, there are tools and proprietary tools by several companies. IBM has some, AWS has these tools that create this virtualization layer and giving access to the data repositories where they are, no matter where they are, on-prem or cloud. Most of these tools, given that they fit in the layers of data fabric of integration layer, the inherent nature of these integration tools is to enable automation. There's a quick time to discover and deliver the value by establishing the connections and then continue to let it drive over a period of time. So there's key aspect that must be looked at when a tool being evaluated to enable a plug and play type of analysis. There's less configuration needed, but there's configuration needed because each of the repository has to be aligned appropriately. So they're not truly plug and play, but they can help you discover the types of data sets, types of data repository, and help you drive the connectivity seamlessly.
All right. Yes. And thank you so much for the question. Thanks so much for the presentation. My question is, will this planning model be the same for a data engineer and data scientist? If not, what would be the difference?
The subtle differences between data engineer and data scientist. Yeah. I often love this debate about engineers versus scientists. So I'll give you an analogy. An engineer is a person who manages the inner workings of data. The data scientist looks at the broad outcome and applies the analytics aspect of it. It's the focus is on the analysis versus the focus on curation and data preparation. So that's the founding differences between the data engineer, who helps acquire, prepare, analyze, and prepare for analysis, versus the data scientist works with partially prepared or semi-prepared data set and starts applying analytical components, either AI-based or machine learning-based, and drive the outcome.
Awesome. Thank you so much. Yes, that's a big question for our students. So would you be able to tell us a little bit about how you came to your role in your career as a data scientist?
Absolutely. My journey started about 26 years ago, roughly, in the space of data. Having gone through bachelor's and master's in computer science, my focus always has been to create integrated platform, integrated views that support various needs for the business. So I had an opportunity to work with Salesforce-based systems back in the late 90s that allowed me to see the data creation and the need for data in a rapidly changing world. The Salesforce team members, when they are working with either doctors or medical offices, they're constantly asking for samples of regulated drugs, and they must track them throughout its life cycle. So every drug is being tracked diligently right from the point of creation, from a manufacturer, all the way to the point of being delivered to the doctor's office or to the pharmacies. And what I noticed is that entire value chain or supply chain of the movement of data was highly regulated. Number one. Number two, it was disparate. It came from one system, went to another system, and it had so many hoops to go through in order to get to one person who is on the field, has to have the information about which doctor he's going to go to, how much drops of samples he's going to drop off, and where it's coming from, whether he has the batch or not, and what are the NDC numbers associated with that. All of the information were available to him at the fingertips, all of them maintained in near real time from a variety of sources. And that was the power of the data that I saw back in the late 90s. After that, I got a chance to work with an organization that allowed me to work with enterprise resource planning systems for multiple geographies, for one specific industries, working in different geographies across the world, allowed me to see how the data is being utilized and regulated in different parts of the world. When I joined IBM, I applied the knowledge that I had acquired before, and I gained different industry specific knowledge. So I started off with one industry, moved into aerospace and defense, moved into pharmaceutical industries, chemicals industries, consumer product goods, several different industries, and I supported all of them for their data needs. That gave me an understanding and a solid foundation, supported by a solid foundation, is to understand the value of the business and how business looks at data differently based on the industry. And there came the challenges that were tied to the industry. Underlying data remained the same, common data remained the same. However, the value and the outcome that the business was looking for were a lot different at every different industry. The rate at which they were looking at were a lot different. The example that I gave you about a consumer product being launched in Asia Pacific versus a consumer product launched to be delivered or launched in Europe, we're from that type of dynamic world where the decisions are made just to stay ahead of the competition so that you can get into the market a lot faster with innovative flavors or innovative approaches or the design that you just released. And that tapping into the market base is extremely valuable and important.
Absolutely. Thank you so much. And thank you so much for your time today and for this wonderful talk and all these amazing insights that you've provided us with today. We really appreciate it. I want to thank all our participants for joining and for asking questions that were super engaging. Yes. Our participants are saying thank you so much. It's very informative and very insightful. We appreciate your time, and we hope you'll return and continue to engage with us at the Data Science Institute.
Thank you so much for the opportunity. Thank you, everyone, for the questions.
Right, thank you. Have a good day.
Thank you. Bye.
Bye-bye.